Okay. But we do need to review graphing piecewise functions. And this was covered in Algebra 2, but when I was talking with the other teachers for PreCalc, they mentioned that some students have a rough time remembering it, so it's worth reviewing. I'm just going to kind of take this straight through as a quick review then. Remember that these qualifiers tell me what's happening at all the key locations when I draw my graph. So it's the function values are -1 as long as my x's are less than 0. So when I draw this graph in here, I'm not going to use that color. Let's use that one. When I come in here at -1, what happens when I get to x is equal to 0? Open circle? Okay. What happens for statement number 2? That was statement 1. What about statement 2? How do I graph that?
Closed circle on the origin.
Put open or closed circle? Closed. So when x is 0, I'm right smack there at y is 0. What's the last thing going to look like? Okay, open circle up here at 2. And I continue on, right? And so that would be my piecewise function. Now these are functions, which means every x gets used once. So you want to make sure that when you're graphing it, you're leaving the open circles and the solid dots in the right spots to show that there is a certain, not a true continuity, but a general continuity. What question is going to answer about that in particular?
Just keep it there for a second.
All right, what about this one? We're going to graph this guy. Start off with an axis and get some stuff on here to work with. Looks like my key points are going to happen actually all in the positive x's. So I'm actually going to draw my axis a little off center so that everything is over there. It says it's 3x if x is less than 3. So let's put some points on here to help out. If x is 0, I'm at 0. X is 1, I'm at 3, right? So 1, 2, 3. Let's actually go up by 2. So 2, 4, 6, 8, 10. So here's 3. Is that an open or closed dot?
Open.
Open? And so there's that first part of it. That happens at 3.
Okay, doesn't it keep going past the origin?
Oh, yeah, it does.
Wait, I'm confused.
Okay.
Why is the line going like I don't get it. You don't explain it.
Okay. This line is y equals 3x, right? We're okay with that?
Why?
Because I'm taking this first part right here, this first statement.
Yeah.
I'm graphing f of x is equal to 3x. So that's y equals 3x. Goes up through the origin. This point right here is 3, 9. And I'm going to stop there because I'm not actually going to include the point 3. If I look here, it says 3 is left out. Up to, but not including 3. So I'm going to draw my line like I normally would. So I start down here and I go up through the origin. I keep going through, like this point right here is 1, 3. Right there. And then 2, 6 is right here. 3, 9 is right here, but I'm not going to include that end point. And if you're not sure, if you're a little shaky on this still, what you can do is draw the whole line and then just erase the extras. You're going to go follow your x's until you get to 3, and then you can just erase everything past that. The second one says 2x plus 1 from 3 to 6. So this is another line. Goes through the origin, and it has an intercept of 1, has a slope of 2. I'm going to use some point plotting to fill these in between 3 and 6. So at 3, that's 6, that's going to be 7. So 2, 4, 6, that's going to be right here. Solid or closed now? Solid. And at 6, that's going to be at 11. And there's my second line now.
13.
Did I add it wrong? I did. Let me tilt that up a little bit. I'm actually going to draw it as a dotted line first. So there's at the 13. So that's 6, 13 up there. I'm going to draw the whole dotted line, and the part I'm going to use is just this part here in the middle, between 3 and 6. And this bottom point down here, that's 3, 7. What happens when x passes 6? What's my last part of this function?
A equals y equals 10.
Flat line at 10. So here's 10, and now it's a flat line from there on out.
$40.